All right, so right now, I know this was a lot of theorems and theory that we threw at you on the last video. And I want to just, for now, I want to just do some examples that will help you get through the homework we have from this section on section 4.6. And then we can go from there we'll get into more details on the next section. But these next 6 examples are very similar to ones you'll see on your homework on my math lab. So in example 1, if f is a polynomial and x plus 3 is a factor of f of x, well, what's f of minus 3? Okay. Well, for this we use our factor theorem. Okay, because if this is saying x plus 3 divides f of x, and if you remember the factor theorem that we just looked at, says that x minus c divides f of x if and only if f of c is 0. All right, so that's going to be the remainder. So f of negative 3 is just 0 because it's a factor. The next example, if f of x is equal to this polynomial, find the remainder when f of x is divided by x minus 2. Is x minus 2 a factor of f of x? Now the nice thing about this is we don't have to use long division if we don't want to, and most of the time we don't want to, because we're just trying to find what's the remainder. Well, the remainder, if you recall from the remainder theorem, the remainder is f of c. When f of x is divided by x minus c, it's f of c. So the remainder when f of x is divided by x minus 2 is in fact f of 2. Okay, so that's going to be 4 times 2 cubed minus 7 times 2 squared minus 6 times 2 plus 8. And this is 32 minus 28 minus 12 plus 8. Okay, and this turns out to be 0. Okay, so the remainder is 0. And because the remainder is 0, that means this x minus 2 is a factor of f of x. So the answer is yes. X minus 2 is a factor. Let's do the next one. Why don't you pause the video and do this yourself? Okay. Almost the same question, or basically it is the same question. You want to find the remainder when f of x is divided by x plus 1. Now this is the same thing as saying x minus 1. Okay, so the c in this case is negative 1. So we want to compute f of minus 1. So that will be the remainder. This is going to be 2 times minus 1 to the 6th, minus 8 minus 1 to the 4th, plus minus 1 to the 3rd, minus 8. And I believe this is going to be 2 times 1, that's 2, minus 8 times 1, that's minus 8, minus 1, minus 8, which is, I believe, it's going to be negative 15. Okay, so the remainder is negative 15, and since this is not 0, we get x plus 1 is not a factor. Finally, the potential zeros of this polynomial. We can see that if p over q is a rational 0, p has to divide 10. So p is going to be plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. Those are all the possible values those are all the divisors of 10. And q has to be a divisor of 2. So q is going to be plus or minus 1 or plus or minus 2. And then we just take all the possible quotients. So This divided by this is plus or minus 1. This divided by this is plus or minus 2. This divided by this is plus or minus 5. This divided by this is plus or minus 10. Then we divide by 2. This divided by this is plus or minus 1/2. Plus or minus this divided by this. Plus or minus 2 divided by plus or minus 2 is going to be plus or minus 1, and we already have that here. Then we have plus or minus 5 divided by plus or minus 2. We'll get that 5/2. And then plus or minus 10 divided by plus or minus 2 is plus or minus 5, and we already have that. So we just have these 12 candidates. And thankfully, we do not have to plug these in because we're not asked to find what if any of them are zeros. So we're all happy about that. So these are we just want to find the potential zeros, the potential rational zeros in this one.